Hello, 5th graders. Welcome to lesson 2.4, Interpret the Remainder. Let's get started. Today's lesson objective is I can interpret remainders from division word problems by using the standard algorithm with 100% accuracy in multiple attempts. Please pause to write the lesson objective in your digital math notebook. In today's lesson, we're going to be interpreting the remainder. That means we need to decide what to do with it. In this lesson, you're going to have 4 choices. Either we're going to drop it, which means we ignore the remainder and only use the quotient. We might do this when we see the word full or whole, and it might be when we can't easily split up an item. We might add it. And when we add it, that would be if we need to put everyone on the bus. So we can't leave anyone or anything behind. We could also share it, which means that we're going to use our remainder as a fraction, just like we practiced a couple days ago. And we would do this when we talk about food or money or measurements. And our last choice is we can use it. So sometimes it will ask us what is left over or left out. And this is where we would use only the remainder. Let's try a division problem and see what we're going to do with it. Here's our problem. Scott and his family want to hike a trail that is 1,365 miles long. They will hike equal parts of the trail on 12 different trips. So 1,365 and 12. How many miles will Scott's family hike on each trip? So as we did this, over here in the blue box, it says circle the dividend. We did that. And underline the divisor. Okay, well, I circled it, but the underline. The divisor is 12. So it says, when you solve a division problem with a remainder, you may want to interpret the remainder based on the situation. Sometimes we're going to use the quotient and the remainder. Sometimes we're going to use just the quotient or just the remainder. Let's continue with this problem and see what we're going to do this time. It says we are going to write the remainder as a fraction. We practiced this the other day, but before we can do that, let's go ahead and divide. So 12 has to travel together. How many times can 12 go into 13? It can't go into just 1. It has to go into 13, and it goes in 1 time. 12 times 1 is 12, and we subtract to see what's left over. 13 minus 12 is 1 left over, and now we bring down the 6. Then we start all over again. How many times can 12 go into 16? That's still 1. 12 goes underneath, and we subtract. 16 minus 12, 6 minus 2 is 4, and then we bring down this 5. We ask ourselves how many times can 12 go into 45? And we get the answer 3. 12 times 3 is 42. So we subtract and we're left over with 3. Now let's look at these questions to see where in all this math our remainder is going to be used. So it says the blank represents the number of trips that they plan to take. Okay, so it told us that they're going to take 12 trips. In this example, 12 is our divisor. The blank, the next one says, represents the whole number of the miles they will travel. So that would be the dividend. The blank represents the number of miles left over. So our leftover part is always at the bottom, and that's called a remainder. Now, in this case, if I hike 1,336, then I did this in 113 trips, but I have 3 left over. I can't just stop hiking and decide to live on the trail because I have 3 miles to go and it doesn't divide evenly. So miles are something that we can divide. Miles are a measurement, and we can make this into a fraction. In order to make this into a fraction, we practiced this the other day. The remainder goes on top, 3, and the divisor goes on the bottom, 12. So we could say that they're going to hike 113 and 3/12 times. All right, this is in your digital math notebook. We're going to do some other ways to handle quotients. In our first example, it says, the segment of the Appalachian Trail that runs through Pennsylvania is 232 miles long. Scott and his family want to hike 9 miles each day on the trail. How many days will they hike exactly, this is an important word, 9 miles? So first we're going to divide, and then we're going to decide what to do with our remainder. So 9 doesn't go into 2, it has to go into 23. So 9 goes into 23 2 times, which is 18. And we subtract. 3 minus 8 we can't do, so we borrow and we get 13. 13 minus 8 is 5, and then we bring down the 2. How many times can 9 go into 52? Well, I now know that 9 goes into 54, but if that's too much, so it have to be 9 times 5 is 45. So we subtract 5 minus 2 we can't do, so we have to borrow again. So 5 becomes a 4, and we move over 1, so we have 12 minus 5 is 7, and 4 minus 4 is 0. So our remainder is 7. But our question said, how many days will they hike exactly 9 miles? They're going to have to hike extra on one of those days, but the days that they're going to hike exactly is going to be our quotient. So in this case, we're going to drop off the remainder and only use the quotient. Our answer is 25. What about if we add 1 to the quotient? Well, like I said, they can't just stop hiking and live on the trail forever. They're going to need another day to hike. So they can't quit on day number 25. They need to do one more, 26 days, in order to hike all of the miles. Our last choice is to use the remainder as the answer. If Scott's family hikes 9 miles each day, except for the last day, how many miles will they hike on the last day? So that would be using only the remainder, and the remainder is 7. So Scott, on the last day, will hike 7 miles. Please pause to write this information in your digital math notebook. All right, guys, time for our lesson activity. It says, there are 103 students eating lunch. Each table has 4 students. All of the tables are full, except 1. How many students are sitting at the table that is not full? So first off, we're going to divide 103 by 4. So 4 doesn't go into 1, but it does go into 10 2 times, which is 8. We subtract and we're left over with 2. We bring down the 3. 4 goes into 23 5 times, which is 20, and we're left over with a remainder of 3. So we have all of the tables, 25 tables, have 4 kids at it, but one table does not. One table has the remainder of students sitting at that table. How many students are sitting at the table that isn't full? Type your answers into your digital math notebook. Great job, 5th graders. You're almost finished. Make sure you complete your exit slip before moving on to your next activity. Great job!